The last lesson on this whole topic is conditional probability. Sometimes we're interested in the probability of an event occurring given that another event has occurred. This is known as conditional probability, as it's the chance of an event occurring on the condition that another event has happened. So the thing for your cheat sheet would be this. If A and B are events, then the probability of A, vertical line B, what does that mean? That means the probability of A occurring given that B has already occurred. This can also be read as the probability of A given B. You need to be able to answer Venn diagram, two-way table, and grid questions for these. So get that. I'll also scroll down enough for your first example. I got a group of 25 students, 15 like milk, 17 like iced coffee. 2 students liked neither. 1 student is randomly selected from the class. Let's draw a Venn diagram. What do we call the rectangle again? It started with a U. The universal set of everything. Who are the people that fall into the universal set? 2. They don't like anything. Let's demonstrate the working out again. In a group of 25, 15 and 17 liked iced coffee. Do we know how many like both right now? Does it tell you how many like both? No? So we need to do the working out. I don't know where the overlap is, so I need to do that working out. I demonstrated the first lesson of probability. 15 and 17. What's that total up to? 15 plus 17 would be? Jesus, this is on YouTube. I've got the gifted and talented class. 32. There has to be 32 there in total. And what do I do on purpose? I do it wrong on purpose in the first place. So we go milk and ice. If we did 15 and 17. What do we have? Where is the problem here? Do I have too many? Do I have too many kids right now? How many by what? Like, too far by how many? 9? This is too many by 9. Why? Because I've got 32 in the middle and 2 externally. So we're at 34 kids when there should only be 25. So I'm 9 too much. Where does the 9 go? That goes in the overlap. The overlap's in the middle. Now I take 9 from either side. So 15 take 9, what would that be? 6? And 17 take 9, what would that be? Do we have 25? 9 plus 8, 17, 18, 19, 20, 22, 23, 23 inside, 24, 25 on the outside. We've got the right totals. Double check this. Do I have 15 people that like milk? 6 and 9, 15. Do I have 17 people that like iced coffee? 9 plus 8, 17. Find the probability that a selected student likes milk. I'm teaching you about conditional probability, but the question doesn't have to ask you about that. Has B set any conditions at all? It just asks you, a random kid, what is their chance of liking milk? So the sample space, probability likes milk. What am I choosing from if all it's asking is a kid likes milk? Am I choosing from all the kids? Doesn't say any conditions. I'm choosing all the kids. So the sample space is going to be over 25. How many kids like milk? 15. So it's going to be 3 over 5. Done. P, probability the selected student likes milk, but now it's given that they liked iced coffee. So you do the vertical line, likes milk, given they like iced coffee. What's that going to be? Given that they liked iced coffee, how many kids like iced coffee in the whole thing? What's the sample space of kids that like iced coffee? 17, so it's going to be over 17. How many of those like milk? 9. 9 over 17? Can you get that down, please? There's a year 12 of mine. What's up, you know?
Yeah, just I left my earphone here.
Yeah, go. I'll scroll down so you can see the next example while people are getting down the working out. Can you get example 2, please, of the restaurant owner? All right, next, a restaurant owner collected data below from his customers. We're going to answer these probability questions there. What did I demonstrate? I think it was Monday. What do we do with a table? Do we leave it at that or do we add stuff to it? Extend it to get totals. Dine in, take away total, delivery total. We're going to have the $20 total there and less than $20 there. So add them up because it's going to assist you answering the questions quickly. 12 plus 17 plus 9. There's 38 people that spent less than 20. 31 plus 15 plus 13. There's 59 people that spent at least 20. 12 and 31. 43 people dined in. 17 and 15. 32 people took away. 9 plus 13. 22 people could afford the delivery. I've got something missing from my table. We haven't totaled up the totals. 43 plus 32 plus 22, 97. Let's double check the vertical column. 38 plus 59. 97 is all the people. That's the total. A, find the probability a randomly selected customer spent at least 20. Probability at least 20. Are there any conditions applied to A? No conditions. You're just selecting a person. How many people spent at least 20? 59. That's why we extended over 97. Pretty sure that's not going to cancel down. I'll leave it at that. Done. But now B, find the probability a random person spent less than 20 given they had their meal delivered. We have a condition now. So I need to look at the delivered people. Probability less than 20 given delivered. So what's my sample space when I'm talking about delivered? 22. I'm selecting out of 22 people. How many people spent less than 20? 9. Last one, probability. Find the probability a randomly selected customer dined in given they spent less than 20. So my condition has changed. Dined in given less than 20. What's my sample space for less than 20? 38 over, no, 38's below. How many people dined in? 12. That cancels. 6 over 15, 16, 17, 19. Done. Can you get those down? One more after this, and then we can do your ATAR lesson if you're interested. Get that working out. If you're up to date with the notes, start getting example 3. It's the last one. I roll a pair of dice. All right, let's do this example so you can chat. I brought up the board games and stuff as well because this second semester you're going to finish things pretty quickly. Last one, a pair of dice is rolled. Given that at least one of the dice shows a 6, find the probability that the sum of the rolls is 10. Use a grid. Do you agree with that grid? Does that grid represent 2 dice being rolled adequately? It shows the 36 possible results of rolling a fair dice. This is the tricky one. What's the sample space if you've been told that it's given at least one of the dice shows a 6? What am I colouring in for the sample space? At least one of the dice shows a 6. Question? That's the outside bit? What do you mean?
Like where the 6 is up?
So like that? Is that at least one of the dice is showing a 6? And then this as well? That's the other dice showing a 6. So my sample space contains, is it 12 or is it 11? 11, because you can't count this one twice, yeah? So it's going to be over 11. Find the probability that the sum of the rolls is 10. How many of those dots gives you a sum of 10? 2. 6 and 4. 6 and 4. Is there any other ways on a 6-sided dice that you could get 10? It'd be O. Whoa, here we go. Is there another one? 5 and 5? Anything else? Sorry? That's what I'm trying to ask you. So is that circle that we just coloured in, is that right? No, because it has to have at least a 6, so it's just going to be 2 over 11. Probability, I didn't write up the answer correctly. P, sum of 10 given 6 equals 2 over 11. Your exercises for today after the ATAR video, can you do 16C, 16D? That'll be the end of it. On Friday, you'll get your practice test and cheat sheet paper.